Hi guys, we have discussed about Earth magnetic field. So the Earth magnetic field is to be calculated by using very two important angles, which is known as angle of inclination. So the angle of inclination can define as the angle made with the horizontal axis is known as angle of inclination. And with reference to 0, this angle of inclination we can measure, and that angle is used to measure the Earth magnetic field at a given point. So if angle is downward, so we can say that as positive inclination, or if the angle is upwards above the ground, so that we take as negative inclination. That's just convention. There is no big deal. So second thing, we need to know about declination. So declination is an angle between two meridians, that is magnetic meridian and geographic meridian. Suppose this is the pole of the magnetic north, so that is the location of the geographic south. So the geographic north pole and magnetic north, so they both are at different locations, and if you are measuring that the angle between the two geographic north and magnetic north at a point, so you are right at here, you are measuring the angle between geographic north and the magnetic north, so that angle we define as declination angle. So with the help of these two, angle of inclination and angle of declination, so we try to measure the magnitude of the magnetic field at a given location. So let us try to get an expression for this magnitude of the magnetic field by relating elements of Earth magnetic field. So the Earth magnetic field at a place can be completely described by three parameters. So the three parameters are, one is magnetic declination, second one is angle of dip, and third one is horizontal component of Earth magnetic field. So magnetic declination, it is the angle between the geographical meridian and the magnetic meridian. So if you can see the diagram, you need to draw two meridian planes. So the angle between the two planes, which is known as angle of declination. So this is the angle between the geographic meridian and magnetic meridian. So that angle help we need it. And second one is dip angle. Dip angle defines as the angle made by the Earth total magnetic field with the horizontal direction in the magnetic meridian is called angle of dip. So for that we need a dip circle or dip needle. So here we hang one dip needle at here, and the dip needle north is directing towards in this direction, and the dip needle is making an angle with horizontal component of the magnetic meridian. So that point is very important. The angle made by the Earth total magnetic field with the horizontal direction in the magnetic meridian is called angle of dip. So while taking dip angle, so please do care about how we take angle. So that dip angle is supposed to be total magnetic field angle with respect to horizontal magnetic meridian. The dip angle here represented delta. And apart of that, we need to know the third elements, that is known as horizontal component of Earth magnetic field. So it is the component, magnetic field having its component, horizontal component and earth component. It is a component of earth magnetic field in the horizontal direction of the magnetic meridian. So that here we can mention as B suffix H. So B suffix H equal to horizontal component, which is making an angle delta, that equal to B cos delta. So this is very main important equation. Now here delta is the angle between magnetic horizontal component of the magnetic meridian and the total magnetic component. How did you get the total magnetic component? You are having dip circle. Take the dip circle help. So then the needle shows the direction. So that is the direction of the total magnetic component. Now if you can take a case at delta at equator. We know that at equator the dip needle floats horizontal. So delta at equator goes to 0. So at equator delta equal to 0, the horizontal component at equator goes to 0. That's why, 0. Then we need to substitute in the cos. I forgot that. So B suffix H equal to B cos 0. Cos 0 value 1. So the magnetic field at here goes to, the horizontal component of the magnetic field goes to maximum, equal to B. But when it comes to poles, here I am having. So when it comes to poles, the delta equal to 90 degrees. So the horizontal component of the total earth magnetic field equals to 0. Only here we are calculating the horizontal component. Suppose if I write the relation between elements of Earth's magnetic field. So this is a very small relation. So that to relate that one, so you need this figure. Suppose if I copy this figure, so this figure shows that to find the magnitude of magnetic field at a given location, just hang vertically dip circle. So the dip needle shows an angle, and there itself you draw magnetic meridian. So that angle we have to measure from the horizontal component of magnetic meridian. So that we can write that horizontal component of magnetic meridian B suffix H equal to B cos delta. Okay, if you got a doubt, then what is the use of geographic meridian? So geographic meridian is useful to locate the magnetic meridian, that's itself. So how we can locate that? By measuring declination angle. The declination angle you can just measure with the compass needle. Okay, I hope you got that. What is the use of the geographic meridian? Now when it come back, so the horizontal component here equal to B suffix H cos delta, and the vertical component B suffix V equal to B sin delta. Let's divide these two. So we can get that B horizontal upon B vertical equal to, so B gets cancelled, then it becomes tan delta. Now let it equation 1. Suppose if you square and add equation A and B, suppose if it call this as equation A, now we can square and add A and B, it means A square plus B square. So we can get that the horizontal component of earth magnetic field plus the vertical component of earth magnetic field equal to, so B square of cos square delta plus sin square delta. So you know that cos square delta plus sin square delta value gives 1. So b horizontal square plus b vertical square equal to b square itself. Now we can get the magnitude of the magnetic field B equal to under root of horizontal component square plus vertical component square. It's simple equation, we got it. So this gives the magnitude of the magnetic field at that location. What about the direction? The direction itself gives by the delta. So this is how the relation between the elements of earth magnetic field, that is declination angle and inclination angle or dip angle, and the horizontal component of earth magnetic field.